Question 19. Find the stationary points on the curve negative x to the power of 2 over 2 plus y to the power of 2 over 3 equal 1. Here in this function he asked to find stationary points. If we want to find stationary points for any function, it means we have to find the first derivative and then we have to put the first derivative, which dy by dx equals 0, and solve the equation to find the values of letters x and y. We'll find x, then substitute to find y. Whatever the form of the expression, we'll differentiate according to its form using the rule. Here, as we can see that this expression or this function is an implicit function. So we'll differentiate first to find dy by dx. But first we can write it in this form: negative 1 over 2 x to the power of 2 plus 1 over 3 y to the power of 2 equal 1. Here two parts between them plus or minus, will differentiate each part separate according to its form. Here we will multiply by the power, subtract 1 from the power, so it will be negative x, plus multiply by the power, subtract 1 from the power, it will be 2 over 3 y. Here in this part we will add dy by dx, or you can write it as y dash. So we'll differentiate each part normally according to its form, but in the part in which we will apply the rule of differentiation on letter y, like this, we will add dy by dx. Here we apply the rule on the letter x, so we didn't add anything. Differentiation of 1 equals 0. Second step, we have to make dy by dx subject, or to write dy by dx in one side and all other parts in the other side. So it will be 2 over 3 y dy by dx equal to, move negative x to the other side, it will be x. Here we'll divide by 2 over 3y, divide by 2 over 3y, cancel, then dy by dx equal 3x over 2y. As we get dy by dx or y dash, we have to put it equal 0 and solve. And here we have an important remark: if we have any fraction equal to 0, it means only numerator equals 0. You have an expression in the form of a fraction and its value equals 0, it means only numerator equals 0. So 3x equals 0, from it x equals 0. This is x coordinate of stationary points. What if we want to find y coordinates, or we have to find y coordinates, but we will substitute by x. In which expression? To find any coordinate, x coordinate or y coordinate, we have to substitute in the original function, not in the first derivative, not in the second derivative. So here, as we put x equal 0, we'll find the values of y. Here y power 2 over 3 equal 1, because this expression equals 0. So y power 2 equal 3. Take square root, and don't forget, as we said before, positive and negative. So here we have 2 points, 0 and root 3, 0 and negative root 3. Here we have 2 stationary points for this function. Question 20. Find the equation of the normal to the curve y equal 3 to the power 2x at the point 0 and 1. In any question, if you ask to find the equation of tangent or equation of normal, steps are similar. You will find dy by dx and substitute with the point to find the gradient, and use one of the two forms of the general form of the equation of the line, because tangent or normal represented by line. The two forms of equation of a line are y equal mx plus c, or y minus y1 equal m multiply x minus x1. So after finding the gradient, you can use any one of them to write or to represent the equation of the line, or the equation of normal or tangent. First, y equal 3 to the power of 2x. We want to find the first derivative, so y dash equal. Here, this is exponential function, but the base is not e. If the base is e, we have two parts for the differentiation, the function multiplied by differentiation of the power. If it's a number, otherwise e, there are three parts. The first part, write the same function. Sorry, it's not e, it's 3. Write the same function. Multiply differentiation of the power, it's 2. And here this part, len of the base. So why here we added this part and we didn't add it if it's e power? Because if we added this part, it will be len e. Len e equal 1, so mentally we cancel it because it will not affect the answer. Here we write it in another form. It will be 2 len 3 between brackets, multiply 3 to the power 2x. After finding the first derivative, you have to put or to substitute with this point or values. It's at this point equal. We'll put x in the place of x and y in the place of y, because sometimes in the expression we have one letter or two letters. So it will be 2 len 3 multiply 3 power 2 multiply 0. So it will be 2 len 3. Usually the value you will get by substituting in the first derivative is the gradient of tangent. Usually it's gradient of tangent. So substituting by the point in the first derivative gives the gradient of tangent. If you want the equation of tangent, you will take the same value in the place of m, in this form or in this form. But if he want equation of normal, as he asked here, the gradient will be upside down change sign. So it will be 1 over 2 len 3 and change the sign to be negative. Here, after getting the gradient, we will use any of these two forms. So I'll use the second one, y minus. This is x1, this is y1. Y minus 1 equal negative 1 over 2 len 3 multiply x minus x1, which is 0. So it will be y minus 1 equal negative 1 over 2 len 3 x. And then if we want to write it in the form y equal mx plus c or ax plus by plus c equal 0, you can do it. If you want to write it as y equal mx plus c, just move negative 1 to the other side. So it will be y equal negative 1 over 2 len 3x plus 1. This is the first form. Or you can collect them in one side and make the other side equal 0. So it will be 1 over 2 len 3x plus y minus 1 equal 0. Here we move this part to the other side and write in order: the part of x, then the part of y, then the absolute term. And then here we have two forms for the final answer. You can choose any one of them. Pay attention, here we get the gradient in this form, negative 1 over 2 len 3. It's better to leave it in the same form. Don't write as decimal till the final answer. It will be better or more simple to write it or to leave it in the same form. Don't write it as decimal. Question 21. If f of x has a minimum point at a and 0 and f dash of x equal x minus 2 e to the power negative x, find the value of a. Here, as you can see, he is talking about minimum point. To find minimum point or to identify minimum point or maximum point For any function we have some steps. The first step, find the first derivative and put it equal 0 to find the stationary points, and substitute in the second derivative to know its maximum or minimum, or this stationary point is maximum point or minimum point. In a question like this or any similar question, we have to pay attention what we need, or what we ask, and what he gives. We said the first step to find minimum or maximum point is to differentiate to find the first derivative. Here in this question, did he give the function and we have to differentiate to find first derivative? No. Here he gives already the first derivative, so we don't have to differentiate this expression another time to find the first derivative. So we will put this first derivative equal 0 direct. This is the second step. We said the first step, find f dash of x and then put it equal 0. He already gives here f dash of x, so turn to the next step, which is putting f dash of x equal 0 and solve. It will be x minus 2 e to the power negative x. Here we have already factorized the expression equal 0, so we can solve x minus 2 equal 0 and e power negative x equal 0. This one is refused because there is no value we can put in the place of x, so the value will be 0. So we have only one choice, x minus 2 equal 0. So x equal 2. Third step, we have to find the second derivative and substitute by this value to know this point is maximum or minimum. Here this is the first derivative, so to find second derivative we have to differentiate only another one time. Here this expression is written in the form of multiplying, so we'll use product rule. First expression or the first part, second part, differentiate its 1, differentiate its negative e power negative x, cross multiply and between them plus, so f double dash of x equal e to the power negative x minus e to the power negative x multiply x minus 2. Here we have to put the value of x in its place in the second function, in the second derivative, so f double dash of 2 equal e to the power negative 2 minus e to the power negative 2 multiply 2 minus 2. This part equals 0. So f double dash of 2 equal e power negative 2. We can here see that using calculator that this value or the value of this expression e to the power negative 2 will give a value bigger than 0. If the second derivative gives value bigger than 0, so it's minimum point because it's bigger. If it's smaller, it will be maximum. So here if we put it x equal 2 in this expression, you will get minimum point, so a equal 2. Why a equal 2? Because a is in the place of x, and we said the value of x which makes this point minimum is x equal 2, then a equal 2, and this is the final answer.